There is a plant growing through the cracks in your sidewalk right now that can fight drug-resistant bacteria better than some prescription antibiotics. Not in theory. It has been healing infections for thousands of years, saved lives across 4 continents, and in 2018, scientists discovered its leaf extracts outperformed chlorhexidine, the gold standard hospital disinfectant. The pharmaceutical industry has spent decades making sure it stays classified as a weed. In 1950, Alexander Fleming stood before the Nobel Prize Committee with a warning. The man who discovered penicillin told the world that bacteria would eventually outsmart our antibiotics. He was right. By 2024, more than 1 million people die each year from infections that antibiotics can no longer cure. Deaths from methicillin-resistant Staphylococcus aureus, MRSA, have more than doubled since 1990, rising from 57,000 to 130,000 annually. The Lancet projects that by 2050, antibiotic-resistant infections will kill 39 million people. That is more than cancer and heart disease combined in some regions. The solution we desperately need is growing in every continent where humans live. This is Biden's Pelosa, the plant that traditional healers never stopped using, and that Western medicine refuses to prescribe. When Spanish colonizers arrived in the Americas in the 16th century, they documented something remarkable. Indigenous peoples across Mexico, Central America, and South America were treating infections with a plant they had cultivated for generations. They used it for wounds that would not heal, stomach infections, dysentery, and fever. The colonizers called it by various names: achatila, mozote, amorceco. The indigenous peoples had their own names, passed down through centuries of use. Across the Pacific, Chinese healers had been using the same plant since at least the 7th century. They called it xian feng cao. Traditional Chinese medical texts describe it as a remedy for clearing heat and removing toxin. They prescribed it for enteritis, bacterial dysentery, pharyngitis, and infected wounds. In Japan, it became the primary ingredient in kampo tea, a traditional medicine still used today for inflammatory skin conditions. In Africa, the plant appeared in traditional medicine systems across the continent. In Uganda, the Bafumbira people applied fresh leaves directly to open wounds and called it inyabalasun. South African healers used it for headache, kidney problems, malaria, and as an antidote to poison. In Vietnam during the war, soldiers adopted it as a food source and medicine, leading to its local name, the soldier vegetable. In Kenya, it was called michicha and eaten as a nutritious green, valued for both food and healing. 4 different continents, dozens of distinct cultures, all independently discovered that this plant could fight infection. What did they know that we have forgotten? In 2014, researchers in Brazil decided to test Biden's Pelosa against one of medicine's greatest threats: oxacillin-resistant Staphylococcus aureus. These are the superbugs that spread through hospitals, resistant to multiple antibiotics, killing patients who survive surgery only to die from infections weeks later. The researchers tested extracts from the plant's roots, stems, flowers, and leaves against 60 different strains of resistant bacteria. The results were extraordinary. The leaf extracts inhibited growth of every single strain. The mean inhibition zone from Biden's Pelosa leaves was significantly higher than chlorhexidine, 0.12%, the antiseptic used in hospitals worldwide. This was not a weak effect. This was a plant extract outperforming pharmaceutical-grade disinfectants against bacteria that kill over 100,000 people each year. Other studies followed. In 2018, researchers tested Biden's Pelosa against waterborne bacteria that cause diarrhea, one of the leading causes of death in developing countries. All bacterial species tested were sensitive to different extracts of the plant. The antibacterial activity ranged from strong to exceptional, with minimum inhibitory concentrations between 0.6 and 10 milligrams per milliliter. These are concentrations that actually work in real-world application. A 2021 study examined Biden's Pelosa against sexually transmitted infection bacteria. The dichloromethane extract showed significant activity against Neisseria gonorrhoeae, the bacterium that causes gonorrhea, and Gardnerella vaginalis. Multiple extracts were effective against Candida albicans, the fungus responsible for persistent yeast infection. Another study tested it against aquatic bacteria that devastate fish farm: Aeromonas hydrophylla, Aeromonas dechensis, Edwardsiella, Ictaluri, and Streptococcus agalactiae. Biden's pilosa inhibited them all. The plant has demonstrated antibacterial activity against Pseudomonas aeruginosa, Escherichia coli, Staphylococcus aureus, Bacillus subtilis, Enterococcus ficalis, and Klebsiella pneumonia. These are not obscure pathogen. These are the bacteria that cause urinary tract infection, wound infections, and meningitis. These are the infections that send people to emergency rooms. These are the infections that antibiotics are increasingly failing to cure. So why does this plant work? Scientists have identified more than 201 active compounds in Biden's pilosa: 70 aliphatics, 60 flavonoids, 25 terpenoids, 19 phenylpropanoids, 13 aromatic compounds, and 8 porphyrin. These compounds attack bacteria through multiple mechanisms simultaneously. The flavonoids and phenolic compounds disrupt bacterial cell membranes, causing them to leak and collapse. They inhibit cyclooxygenase, the enzyme pathway that leads to inflammation. They interfere with quorum sensing, the communication system bacteria use to coordinate infections and form protective biofilm. They bind to bacterial DNA, preventing replication. They inhibit the enzymes bacteria need for energy production and protein synthesis. The polyacetylenes in Biden's pilosa are particularly fascinating. These compounds strongly absorb ultraviolet light and become activated by sun exposure. This makes them especially effective for topical application. When applied to infected wounds and exposed to sunlight, the polyacetylenes become more potent, killing bacteria, yeast, and even insect larvae. This is why traditional healers across multiple continents independently discovered that fresh Biden's pilosa leaves applied to wounds and left exposed to air-healed infections faster than wounds treated any other way. Studies have confirmed this traditional knowledge. A 2017 study showed that Biden's pilosa extract demonstrated antibacterial activity against E. coli with an 18.2 millimeter inhibition zone at 10 milligrams per milliliter, compared to standard ampicillin at 30 micrograms per milliliter. The plant was competitive with pharmaceutical antibiotic. In 2016, researchers tested whether Biden's pilosa extracts could preserve meat. They treated ground beef with the extract and stored it at cold temperatures for 6 days. The plant extract lowered total viable bacteria and lactic acid bacteria counts better than the control and better than BHT, butylated hydroxytoluene, the synthetic preservative commonly used in food. The broad-spectrum antibacterial activity worked with minimum inhibitory concentrations between 0.6 and 10 milligrams per milliliter against foodborne pathogen. The evidence is overwhelming. The plant works. Traditional medicine was right. So why is Biden's pilosa not prescribed alongside or instead of failing antibiotic? The answer begins with patents. You cannot patent a plant that has been growing wild for thousands of years. You cannot patent traditional knowledge used by indigenous peoples across 4 continents. You cannot create a synthetic analog that works better than the whole plant extract when the plant already contains 201 bioactive compounds working synergistically. Pharmaceutical companies invest hundreds of millions of dollars developing new antibiotics. Between 1960 and 1980, the industry experienced a golden period, producing numerous new antimicrobial. After 1980, development significantly declined as companies shifted focus toward more profitable drug category. Chronic disease medications taken daily for life generate far more revenue than antibiotic taken for 7 to 14 days. According to industry analysts, pharmaceutical companies will not invest in drug testing for botanicals because proprietary claims remain unclear. Richard Vandenbroek, industry analyst, stated that most novel antibiotic research is being conducted by biotechnology companies, not major pharmaceutical firm. The financial incentive simply does not exist. Between 1999 and 2014, fewer than half of new antibiotics that entered the market were made available in more than 10 countries. And those countries were predominantly wealthy nations. The World Health Organization's latest review identified only 27 antibiotics in clinical development that address bacterial priority pathogens, and only 6 were classified as innovative. The clinical pipeline is nearly dry. We face an antibiotics pipeline and access crisis, while a plant with proven broad-spectrum antibacterial activity grows wild in every temperate and tropical region on Earth. There are other barriers beyond patents. Clinical trials for botanical medicines are expensive and complex. Biden's Pilosa contains multiple active compounds that vary based on growing conditions, harvest timing, and extraction method. Standardization is challenging. What works in a laboratory may not scale to commercial production. Pharmaceutical-grade extracts require controlled cultivation, standardized extraction protocols, rigorous testing, and regulatory approval. All of this costs money with no guarantee of exclusive rights at the end. Meanwhile, synthetic antibiotics, even as they fail, maintain market dominance through established regulatory pathways and intellectual property protection. The system is designed for synthetic drugs, not traditional plant medicine. The consequences are devastating. The Global Antibiotic Resistance Surveillance Report from 2025 analyzed more than 23 million bacteriologically confirmed cases of bloodstream infections, urinary tract infections, gastrointestinal infections, and gonorrhea from 110 countries. Resistance levels are rising. Deaths from carbapenem-resistant bacteria increased from 127,000 in 1990 to 216,000 in 2021. Third-generation cephalosporin-resistant enterobacterales now appear on the WHO critical priority pathogen list. These are bacteria resistant to our last-line antibiotic. 80% of the world's countries have extremely limited access to effective first-line antibiotic. Newer antibiotics that target resistant bacteria are even scarcer. More people are dying from lack of access to effective antibiotics than from drug-resistant infections. And this lack of access accelerates the rise and spread of resistant. If current trends continue, antibiotic-resistant infections will cause 169 million deaths between 2025 and 2050. The Lancet estimates that improving access to antibiotics, including alternative treatments, could prevent more than 50 million of those deaths. Biden's Pilosa represents exactly the kind of accessible, affordable, broad-spectrum antimicrobial that could save millions of lives, especially in low and middle-income countries where the plant already grows abundantly. Half the world never stopped using Biden's Pilosa. In China, it remains a mainstream herb in traditional medicine, collected and used by people to treat common ailments. In Mexico, young leaves and flowers are used for stomach disorders, hemorrhoids, and diabetes. In Africa, it continues as both food and medicine, valued for treating infections, inflammation, wounds, and dozens of other conditions. In India, it treats glandular sclerosis, wounds, colds, flu, hepatitis, and urinary tract infection. Western medicine abandoned plant-derived antimicrobials when penicillin arrived in the 1950s. Of the 25 to 50% of pharmaceuticals currently derived from plants, very few are intended for use as antimicrobial. We relied on bacterial and fungal sources, assuming they would always provide new options. The plant that could help address the antibiotic resistance crisis is classified as one of the world's most common weeds. Agricultural extension offices publish eradication guide. Herbicide companies sell products specifically formulated to kill it in lawns, gardens, and agricultural fields. Homeowners associations prohibit it. The entire infrastructure of modern horticulture treats Biden's Pilosa like an invasive enemy, not because it damages ecosystems, but because it grows everywhere without permission. Biden's Pilosa is an annual herb that grows 30 to 100 centimeters tall. It has bright green leaves with serrated edges and small yellow flowers with white ray florets. The seeds are black, thin, and equipped with barbed bristles that attach to clothing and animal fur, one of nature's most effective seed dispersal mechanisms. This is why it has spread globally, why it appears in driveways and gardens, and vacant lots across every inhabited continent. It grows in disturbed soil, agricultural fields, and urban waste area. It tolerates a wide range of conditions and produces hundreds of seeds per plant. It is extraordinarily difficult to eliminate once established. These characteristics that make it a successful weed also make it an accessible medicine. It grows where people live. It requires no special cultivation. It costs nothing. Learn to identify Biden's pilosa. The leaves are pinnately compound with serrated leaflets. The yellow flowers have white outer petals. The black seeds with hooked bristles stick to fabric and fur. When harvesting, choose young leaves and flowering tops from plants growing in clean soil away from roads and chemical treatment. The leaves can be eaten raw in small amounts, though they have a slightly resinous taste. They can be cooked like spinach, added to soups and stews, or dried for tea. Traditional preparation involves making a decoction. Boil 1 to 2 teaspoons of dried aerial parts in water for 10 to 15 minutes. Strain and drink up to twice daily. This is not medical advice. This is acknowledgement that indigenous peoples, traditional healers, and half the world's population have used this plant safely and effectively for thousands of years, while Western medicine has spent 7 decades pretending it does not exist. The pharmaceutical industry does not want you to know that a plant in your driveway demonstrates antibacterial activity against MRSA comparable to hospital-grade disinfectant. The regulatory system does not want you to know that standardizing and approving plant medicines threatens the profit model of synthetic drug development. The medical establishment does not want you to know that traditional knowledge, dismissed as folklore for generations, is being validated by peer-reviewed scientific studies showing exactly what indigenous healers said all along. This plant fights infection. More than 1 million people died from antibiotic-resistant infections each year between 1990 and 2021. That number is projected to increase by nearly 70% by 2050. We are losing the war against bacteria because we abandoned the plants that fought alongside us for 4,000 years. It is called Biden's pilosa. It has been treating infections across every inhabited continent for millennia, and it is growing in your driveway right now.